when you're ready. If you're in the middle of a question, maybe when you finish that, we'll continue. Are you in the middle of a question, Felicia? Or you just finished one?
Well, I think indeed up to 5 was over 5. Can I ask a question on it?
No,
Later? Okay.
no, I think it's good that you got the first 4 done. How many's left to do?
First.
Okay, that would be good for homework to try. And then we can do it, we'll have a tutorial, I don't know when, this week or next week. We can do some problem questions. Yeah, which one are you to finish, Ben?
3.
Okay, that's good. We'll continue. RC circuits. Yeah? Oh dear. This was hard, excuse me. I'm so tired and hungry and tired. Okay. RC circuits and graphs. Other things to do. Right. So the capacitor is fully charged up, then is allowed to discharge through a resistor, like a light bulb. So let me just draw the diagram, okay? So maybe you have something like this. You have a battery. Yeah. A capacitor here. Yeah. And let me draw that a little bit better, sorry. Hang on, I don't get confused. Yeah, then it comes down here, and it goes across here, and there's a switch here. Yeah. Sorry. Sorry, I drew my picture so badly. Apologies. Okay, close it here. There's a switch here, capacitor here. Yeah, we'll make it a light bulb like this. Okay, so when its circuit is like this, what happens is the current goes around like this, and this charges up. It gets a charge, okay? Then what we do is we press a button, and this gets flipped down there, like that. Okay? So then what happens, the current, goes down here. Around like that. And this causes the flash here. So what I want to do is put a little ammeter here. I want to measure the current, okay? So there's the time, and there's the current. And time 0 means when I push the button. So I push the button at time 0. So what will happen? Well, let's have a look at some example data here. Oh, and notice that this circuit, okay, so in the exam, they don't care about this part, okay? They just care about looking at this part after you press the button and the charge comes out. You notice in this circuit you have 2 things. You have a resistor and a capacitor. That's why we call it RC, a resistor and a capacitor circuit. So anyways, we put in the ammeter and we get some data. So here, this is milliamps and this is seconds. You start off with 100 milliamps, then 70, then 50, then 35, and so on and so on and so on. So it decreases like this. I'll just try and roughly draw that. So if I was to draw that, you know, what have we got first? 100. So we'll make this 100. Oh, and we go up to 10. And this is in, sorry, let me draw it properly. time in seconds, current in milliamps, and we'll make that 100 milliamps. So it starts here, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we start off with 100, and then there's 50, 75, 25. So then the next one is, what did I say? 70. So that's like about here. And the third one, 50. Then the fourth one, it's here. It's like about here. Then the next one, 20, 25. 17. 12. Oh, you get the idea what's happening here. 8, 6, 4. Okay. Blah, 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 blah. So if you were to look at the graph, it goes like this. Where have you seen this graph in maths class? What function is this the graph of? Where have you seen this in maths class? Is it quadratic? No. It's not quadratic. Is it linear? No. Is it sine? Is it cos? No. What is it?
Tan.
Not tan.
It looks like log.
Huh?
Log.
Kind of looks like log, but log is like this.
Oh. A X. No.
Yeah.
What did you say?
Not sine.
Yes, I have a.
It's exponential. It's exponential. It's one of these graphs in maths class.
Okay.
Okay, so what I think will be good for you to put in your notes, if we draw a capacitor, we draw a milliammeter, we draw a resistor, and this is called an OR. Whoa! This is called an OR-C circuit. And if we were to measure the current against the time, so if there's some clock here, we would get a graph that looks like this. Okay, and the name of this graph, Ben, is exponential. See? Exponential. Or, if you don't like that word, you can write EXP for short. Or, for very short, you can just write E minus X. That's the shape. Exponential. Okay, so I think it would be good if you can draw the graph with the circuit. Got that, Ben? Khalifa?
Yes.
Yeah? Nice. Okay. Continue. So, what happens is we can say that the formula we think looks like this. The current I is equal to some constant, I0, e to the minus t divided by some other constant. This is the form we think it is. Okay, so I think you could add this to your graph, that we think this is the function. Did you have that? If you can write this down. Do you know this Greek letter? Do you know this Greek letter? It's called tau. Tau.
Is that C?
It kind of looks like a C and a T. Yeah? Yeah? Okay. Right, so the I0 is going to be 100 in this graph. But what about the 1 over tau? Well, let's see how we can figure that out. Let's calculate the log of I. So I've done it in a table already here. Here's I, here's t, here's the log of I. Now instead, let me plot log of I. Let me plot this. I wonder if I've done it already. No, I haven't. I'll just do it very quickly here. So this is t in seconds, and this is log I in log milliamps, and we start at 4.61. So we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we start about here. So what happens is when you draw it, you get now this graph, which is a straight line. So if you were to plot log I against or versus t, you notice that you now have linear. Okay, so in the exam, when they ask you to draw this, a mistake sometimes students do is they draw this instead of the log of it. Okay, so please be careful in the exam. Usually they want the log of the current. Okay, so they want your graphs to look like this. That's 5 here. Oh my goodness, I'm so tired. Continue?
Yes,
Yeah. Now, notice how it's linear. So,
sorry,
yeah.
in the exam, they're going to give us, for example, this.
Yeah,
I'm going to give us the table.
Yeah.
First. Okay.
and you have to calculate the log I on your calculator.
How?
You have an LL button on your calculator.
Yes.
Well, we're going to get to tau now. So what am I about to show you? In the exam, there are 3 proofs you need to know for the exam. One of the proofs was for UVATS formulas. But don't worry, they don't really ask this in the exam. The other proof was, remember when we did the PV equals 3 over 2 KT? Remember that formula? Yeah. The third proof for semester 1 exam is this proof. What they want you to do is to take this formula and put a log on it and see what happens. So if you can write this down, you imagine you have I equals I0 e minus t over tau. So you put a log here, you put a log here. Okay? So that's log I equals log I0 plus log e minus t over tau. Now, what happens when you have a log and an e? What happens?
Is 1 minus
T over tau, yeah. They cancel. Now, if I was to make a graph here, this guy we said is log y, and this guy we said is t. So log y, log I is like y, and t is like x. Yeah? So this guy is like y, and this guy is like x. So you can write this as y equals minus 1 over tau x plus log I 0. And this is like y equals mx plus c. So m is equal to minus 1 over tau. So tau is equal to minus 1 over m. And you need this proof for the exam, because they sometimes ask this.
Is slow.
Minus 1 over the slope is tau on the graph of log. Yeah, if you graph log I, you get a straight line. The minus 1 over m here on this line is the tau here. This is how you can find tau. This is how you can find tau. There is another way to find tau. We'll talk about it in a minute. Continue.
Tau is like x, y, z, this.
It's just a letter, a constant.
Oh, it's constant.
It's constant for each problem. It's different for each circuit.
Okay.
Yeah. So, this is the result we got, and so y equals log I, x equals t, m equals minus 1 over tau, and c equals log I 0, which you wrote down. Okay. Now, what's nice is this formula is for current. Khalifa, what's wrong? This formula is for current.
Current.
Yeah, I.
Oh, current.
Current. Yeah. So you have this. We did that. But it's the same idea for Q, for charge. Same idea. And same idea for voltage. All these graphs are exponential. Yeah? And if you calculate log, you get a straight line. The tau has a name. We call the tau the time constant. And it can be found using this formula. Minus 1 over the slope, the gradient. But there is another way to calculate tau, interestingly.
Is it easier than another?
Yeah, but it only works if you know OR and C. So if you know the OR and you know the C, then you can calculate tau using this formula. Yeah. So you have two formulas for tau.
Or is gradient.
Huh?
Gradient.
Slope.
What?
It's
Gradient is slow.
another word for it, yeah. Yeah? Yeah? Also note, the time to fully discharge is roughly 5 time constants. So no surprise that the unit for tau is the second. You measure tau in seconds. Yeah. So what I mean is here's the t, here's the I, and it decreases like this. And at some point here, we say it's basically 0 amps, roughly. And that point is 5 time constants. Roughly. Because you know in maths class that, does this graph ever reach the x-axis?
No.
Not technically, no. But in physics we say it nearly reaches at 5 time constants. Is it okay? Are you sure, Ben? Are you sure?
Or else
Tau.
tau equals
Time constant.
RC.
It's also equal RC, yeah.
RC
Yeah.
is slow.
You have two formulas.
Y equals RC.
Oh, I don't know. It's just a formula. I haven't tried to prove it.
R is
Resistance.
resistance. C is
Capacitance.
okay.
Yeah. You could try to prove it. I don't know.
Okay.
I don't know. I don't know, Ben. Let's see. I equals I0 E minus T over tau. Why does tau equal RC?
Okay.
I over I0 log equals minus T over tau. Log I0 over I equals T over tau. Tau equals T over log I. I don't know why it's equal to RC actually.
Okay.
Okay, no problem. Well, it is a problem. I'll have to check. I don't know.
Actually, I0 is 0 or always 100. Or maybe 1000. Okay. Okay.
I'll check it later. But that's the formula, tau equals RC. Right, let's look at this example. A current discharging from a capacitor is measured and recorded every 10 milliseconds. The table below shows the data from the ammeter. Graph this in an appropriate manner. What does that mean? Appropriate manner.
Label each place.
Well, that's certainly true. But what I mean here is, should we graph I or not?
Yes.
Oh no.
Yes. No.
Log I. Log I. Because when I use the word appropriate manner, it means use the correct graph. And the correct graph is not this, not I and T, but instead log I and T, because it's a straight line.
Straight line is
Better.
oh.
Yeah, in physics. And also because we can get the tau. So I'll tell you what we'll do. What's this? Milliseconds. Milliseconds?
Yes.
So it goes 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, and then, right. So, can you just type in ln 1000? What do we get? Okay, one sec. I just want to make a very rough graph. Oh, golly. Okay, let's see. Log current in log milliamps. What did you say you got, Khalifa?
6.90.
Okay, so I'm going to go up to 7 then.
Yes.
1, 2, 3, 4. No. 1, 2, 3, 4, 5, 6, 7. Okay, so what was your first number? 6 point.
9.
So that's basically here.
Yeah.
Yeah, okay. Right, the next one. Log 841.
6.7.
So it's only a little bit less. Okay, so that one was 6.9 and that one was 6.7. So let's just jump down. What's LN 177?
5.1.
Okay, only 5. 5.1.
Okay.
Yeah, you need to be careful, Ben. 5.1. So like this.
It's just going to be a difference.
Just a little inclination of it would seem. Yeah, okay. Anyways, from your graph, estimate the tau. So the tau will equal minus 1 over the slope. And the slope would be, let me see, 6.9 to 5.1. So that's 1.8, isn't it? In height. And this height here is 100. Yeah? Is that right? So it's 1.8 over 100.
It's 1.8 how?
Huh?
How did you get 1.8?
Oh, the difference between 6.9 and 5.1 is 1.8, isn't it?
No.
It's not.
0.2.
No. 6.9 minus 5.1. 6
Okay.
is 1.8?
1.8, yes. I was checking 6.7.
Yeah, okay, so this will be minus 1.8 over 100. So this is 100 over 1.8. Now what's that, please? Don't worry, Ben. Trust me.
500 over 9 equals to 55.5.
Now what's the unit here? What's the unit here?
Meter second.
No. Oh wait, what did you say?
Meter second.
No. Did you say meter second?
Oh, second.
Did you say seconds?
Oh,
Milliseconds.
millisecond.
Milliseconds.
Oh, yes.
Milli.
Yeah,
Not meter.
My fault.
Okay, so that's equal to 0.0555 seconds.
How to calculate the slope?
That is
This over this.
the 6.
Delta y over delta x. And because it's going down, it's minus. Yeah? Is okay? Not okay?
Let me think.
You have this, Ben?
Yeah.
This is called the run, and this is called the rise. And the slope, the m, is also called the gradient. And that's the rise over the run. Yeah? Are you sure?
Yeah.
Okay, I trust you. Right, next. How long until the capacitor fully discharges? That means how long until there's no current? Until the current becomes 0.
0.
Yeah?
0.05.
Yeah? No. No. Remember, I said it's 5 time constants. So you need to take this answer and multiply it by 5. What do you get? What do you get?
0.2775.
0.2775 seconds. Finally, what's the value of the resistor? Now you know the capacitor. The capacitor is 200 millifarads. Okay, so now you can use this formula. tau equals RC. So that means 0.0555 equals R times 0.100. Oh, sorry, 200. Is 200 millifarads. So that means R is 0.0555 over 0.2, which is 0.277 ohms. Isn't it?
0.2775
Yeah. How did I do that so quickly in my head? How did I do this calculation so quickly in my head?
Just divide by 2
I did the two both
and
in
half by 10.
Ah, no. What I did was 1 over 0.2 is the same as multiply 5,
Oh,
which we have earlier.
okay.
Yeah, that's how I was thinking.
Okay.
Yeah. Okay. Right. Yeah. So this would be what you'd get in the exam. Okay? It's not so bad. It's a graph
I
question.
like electricity more than mechanism.
Yeah, I think it's a good exam topic. Okay? So what do you need to write down? Do you need to write this down? What do you need to write down?
Yes.
This is a bit of a mess. Probably should. What, do you want this open or do you want this open? Did you write anything down?
No.
Okay, right, let's
Experience.
I am so hungry. We got this.
Did you have lunch?
Too small. Too small. Soup and 3 slices of bread.
It's okay for me.
That's too small. Too hungry. Too hungry. What did you have for lunch?
Oh, Subway.
Footlong or half? Huh?
Loaf.
Footlong? Nice. What do you like in Subway?
Italian, turkey, and some tomato,
Mm-hmm.
onion, corn.
Yeah, me too. Tomatoes, onion, corn. Lettuce?
Yeah, I love that.
Lettuce is good on the sandwich. Back to the...
No, up.
Oh, I don't think there's anything on the top. Yeah, down.
Yeah.
What meat is on it? Turkey.
Turkey.
Just turkey?
Yeah.
What bread?
Italian.
The Italian bread.
I like the ham and cheese. Then I eat with the meatballs.
Meatballs are good, yeah. Don't know what's my favourite Subway sub. There's some Italian meat one or something. They put lots of different meat on it.
Cheese.
Yeah.
Okay. My favorite was the cheese and stick. Just the beef and the cheese, then the lettuce.
Yeah, that's good too. Yeah. How much is a sandwich at Subway?
Oh,
Yeah.
6 for
The small one
What?
is 4.550. Yeah, 450. The
65.
small one. This big one is 6.
With a drink?
No.
Well, the small one with the drink is 450.
With a drink is 450. And the big one with a drink?
No.
No offer?
Oh, cola. Oh, cola.
That's expensive.
Huh?
Oh, cola.
You forgot about that. Okay, did you write this down?
Yes.
Okay. And do you need to copy anything from this? No, you're okay? Okay. So, that's the question in the book. How many questions did I give you? 2?
In the book 3.
3?
So we can do number 1. From the scene of the number 1.
Yeah.
And
Number 1's a graph, isn't it?
Yeah, I said A to H, but no, A to H. But the voltage after one, for example, calculate the voltage after the time.
Yeah, so for that one, good point. For those questions at the end, you need to use this formula. So after you calculate the tau, then you can use this formula to calculate the V. So if I ask you what's the time at, let's say, 5 seconds, then you just replace the t here with 5, the tau with what you calculate, and the V0, what's that? That's the voltage at the beginning.
At the beginning.
Yeah. Now you can see that in the question.
500.
It starts off at 500 volts.
Okay.
Wait, no, 500 microvolts.
Oh, Michael.
Yeah.
So
Okay.
it's 5 multiplied by
500 times 10 to the minus 6. That's 5 times 10 to the 2. Yeah. That's 5 times 10 to the minus 4 volts. Yeah.
Okay. So what of the current?
Yeah, same idea. So for the current, you can also do the same thing. I equals I0 E minus T over tau.
So here, if I draw the graph, I need L and
Yeah.
V.
Yeah.
Okay.
Yeah.
Okay. That means
Yeah.
still the same thing. After finding the tau, then I'll place it.
Yeah, well, let's see. First, you have the graph.
Yes.
Then, secondly, I just ask you what are the units on your graph. So the units are milliseconds and microvolts, log microvolts. What is your tau? Now, just be careful in part C, your tau will be in milliseconds because time is in milliseconds.
So I use here. I just use like 15 minus volt.
Here,
Yeah, 15 minus volt. So
yeah, you can just say 500 microvolts. Yeah,
no, 50.
50.
Yeah, it's
That's 500.
but you can see here is my minus
Milli.
millisecond, and here is what is it?
Micro.
Micro, and here I just use. Oh, it's okay.
Yeah, it is actually. So if you
Oh,
look,
it's 0.5. It's
no, look.
it's
If here you use log microvolts and here you use milliseconds, and you get the slope here, the tau will be in milliseconds. Now, if you don't use micro, say you use something else like milli or whatever, this doesn't actually change.
Okay.
It doesn't change. It's still milliseconds because this is milliseconds. Now I'll explain, Ben, I'll explain why. Here and here, okay? The slope is the rise over the run. And the run is in milliseconds, yeah? The rise will be log v2 minus log v1. Okay? But you know from maths class that's v2 over v1. So it doesn't matter if it's micro,
Yes.
because they cancel.
Yes. Yes.
Yeah, okay, good. Alright, can I close this?
Yeah.
Okay, can you try? Well, we've got time. Just take 5 minutes. Just 5 minutes. And then you can go. Okay, 5 minutes.
So you are tired.
I'm tired, you're tired, but just 5 minutes, I promise.
Okay. Bye. No problem.
Even if you just graph this, just get the log and graph it. Then you can go. And give it a nice graph. With a ruler, yes, thank you.